Most developers know how to build controllers, but very few truly understand what happens before the request even gets there. If you want to build secure, production-ready apps, you have to master the filter chain. In this video, I am breaking down the Servlet API and Spring security filters, going deep into Spring Boot filters and filter chains so you can master request processing from the ground up. Let's get started. Before we dive into Spring Boot filters, let's first understand in the most general sense what is actually a filter. Think about a coffee filter. You pour water and coffee grounds it from the top. The filter sits in the middle and what comes out the bottom is only clean coffee. The grounds are intercepted and blocked. In the world of web application, a filter works in a very similar way. When a request comes in our application, it does not reach the controller directly. It passes through a chain of filters first, and then the response goes back to the client, and in reverse, it passes through the same chain again. So, a filter sits in between the application and the client. It can intercept it, can modify it, or it can also block it entirely. And it can do the same for the outgoing response. Let me explain all of this in more details. Here in this diagram, we have this client. Here I am showing this Postman and web browser as an example, but it can be anything, any mobile app or any application that is capable of sending HTTP request. So this client, and then here we have the Servlet container. Again, here I am showing this as Tomcat server because most Spring Boot application provides an embedded Tomcat server. So though I have mentioned it as a Tomcat server, but it can be any Servlet container capable of running your Spring Boot application. Now, this portion inside the server is our Spring Boot application. When the client sends a request to the server, it is in the form of HTTP or HTTPS protocol. But since our application is written in Java, we need a Java object to work with it. We cannot work directly with raw HTTP request. For that reason, here in the middle between the client and our Spring Boot application, we have something called the Servlet API. The Servlet API converts this HTTP request into a proper Java object and pass it to our Spring Boot application. Then inside the Spring Boot application, we have a component called the DispatcherServlet. It receives the request and passes it to the appropriate controller. Then the controller performs the necessary work on that object and return it to the DispatcherServlet. And then the DispatcherServlet return it to the Servlet API. Now again, our client cannot directly work with the Java object. It needs the response in an HTTP or HTTPS format. So the Servlet API converts that object into HTTP or HTTPS response and send back it to the client. And that's how we handle these things internally. But considering all of these, where actually this filter sits? Okay, now let's try to understand this filter in detail. Let's move to our second diagram. Here we have our Spring Boot application and over here is our client. As I have mentioned, the filter is part of the Servlet API and that sits right in front of the application, acting as a bridge between the client and the application. So the filter will sit here. Now, what the filter actually is? A filter is basically a reusable, pluggable component that sits between the client and the resource. It intercepts each and every request that comes from the client, and it can also do the same for the outgoing response. Based on the logic we provide inside the filter, it can modify the request, block it, or perform any other necessary action. That means everything is done before the request even reaches our application or the response is sent back to the client. One of the most powerful uses of this filter is in Spring security, which we will see in a moment. But for now, suppose we have a filter. Let me draw a filter here. This filter intercepts the incoming request and and it checks a specific email pattern in the request header. If the pattern matches, only then does it allow the request to pass through the filter and reach our application. However, if a request comes to this filter that does not match the criteria, meaning it does not match the email pattern, it blocks the request and sends an error message to the client. Let's see this in code. I've opened the project in IntelliJ IDEA. On the left side panel, you can see the project. This is a brand new Spring Boot project. If we check the pom.xml, here we are using Spring Boot version 3.5.4 and the Java version 21. And there I added only one dependency. Not this one, sorry, this one. I have only added one dependency. It's Spring Web dependency. The other dependency you see was added by Spring by default, and it is a dependency for testing. Now, if we check our SRC main Java, I have already created a controller. It's a simple REST controller with only one endpoint. It returns the string welcome to home. Nothing fancy, it just makes our work done. Okay, let's start this project and see this in action. The project is started. Let's switch to the Postman. I'll open a new request. Our application is running on localhost 8080. Let's send a request. And here we have this response. The status code is 200 and this is the message that is returned from the controller. Now, let's talk about the filter. As I mentioned earlier, the filter is not part of the main Spring Boot application. It is the part of the Servlet API, which is Java EE specification. Let's open that filter class. To open, I will search this file. I'm going to use a shortcut. I have actually modified my shortcut to Command+P, but if you are using IntelliJ IDEA, I believe that default shortcut may be a double shift. Okay, let's search. So let's search for that. Make sure this all is selected and include non-project item is checked. Now let's search for filter. Here you can see many available filter classes. We need to check this one from Jakarta Servlet. Let's open it. As you can see, it's an interface. This is the Java specification and it's been around since Servlet 2.3. So it's quite old. As I mentioned it previously, it's part of the Servlet API. As this is the specification, so different application and containers have their own implementation of this filter. Tomcat has implemented it in a certain way and other Servlet containers have implemented it differently. Spring also has its own implementation, especially in Spring Security, which we'll check out later. Let's look at the documentation. It says the filter performs filtering in the doFilter method. It also provides some examples of its use case, such as authentication filters that is used for checking the authentication, logging and auditing filters, image conversion filters, and many other scenarios. Right now, let's check the methods available in these filters. Scrolling down, here we have the init method. The Servlet container calls this method exactly once to indicate that our filter is being placed into the service. We use this init method for any setup task we might need, like loading configuration properties or allocating resources before the filter starts handling any traffic. Then we have the doFilter method. This is the most important method and we are going to focus on it in this tutorial. The documentation states that the doFilter method is called by the container. With this container, it means the Servlet container. Each time a request and response pair passes through the chain due to a client request. It also mentions that a typical implementation follows a specific pattern. It examines the request and then optionally wraps the request object with a custom implementation. Here is the parameter of the doFilter method accepts. It accepts a Servlet request, Servlet response, and a filter chain. Think of this filter chain as a sequence of checkpoints. It acts as the link to the next filter in our application's pipeline. Once our current filter finishes its job, We use this chain object to pass the request and response forward so the next filter can take over. In a typical application, there can be several filters. We need to pass the request to the next filter in the sequence. Finally, we have this destroy method. The container calls this method exactly once when it is time to take the filter out of the service. This is our opportunity to clean up any resources we initialized earlier, such as closing network connection or clearing caches, ensuring our application shuts down gracefully. Now, as this filter is an interface, we need a concrete implementation to work with it. Let's try to implement this filter interface in our application and see how it works. In our base package, let's create a new package and name it filter. Inside this filter package, let's create a Java class. I'll name it demo filter. To have Spring automatically manage this class, we need to add the component annotation. This demo filter will implement the filter interface that we just looked at from Jakarta.servlet package. Now, we need to implement its method. Let's implement the doFilter method. So, here is what we are going to do. I'll intercept the incoming request and check its header. Especially, we'll look for a header named email. If the email header is missing or if its value contains the string test, we will reject a request and return a bad request status. However, if email header is present and does not contain the word test, we will allow the request to proceed to the next filter. Let's do this. First, we need to convert the servlet request and servlet response into an HTTP servlet request and HTTP servlet response. Let's declare an HTTP servlet request. Make sure this is imported from jakarta.servlet.http. Name of the variable HTTP servlet request. This equals request. We need to cast it with HTTP servlet request. One thing I want to mention, I could use AI to generate the full code quickly, but I prefer typing it manually so we can understand exactly what's happening line by line. Okay? Similarly, we'll create another variable, HTTP servlet response, and cast the incoming response parameter to an HTTP servlet response. Next, I will extract the email from the header. To get the header value, I will call HTTP servlet request.getHeader. Here we have a couple of options available. I am going to use this one that accepts the header name as a string. And here we are looking for email. And I'll store the result in a variable named email header. Great. Now I will add an if statement. If this email header is null or if it contains the string test, we are not going to proceed further. Here I will add status code and add a message. We can do this using our HTTP servlet response object. First, I will set the status code using HTTP servlet response.bad request. And the status is. Finally, I will write the message to the response body by calling HTTP servlet response.getWriter, then write. And here the message I will show, please provide a valid email address. And now, if this checking passes, that means the email header exists and does not contain the text test. So we'll pass the request to the next filter. To do this, we'll call chain.doFilter, provide a request and response object. Okay, now let's restart the project and see what happens. I'll stop and return it. Back in the Postman, let's check our headers. At this point, I am not sending any email in the headers. Even in the hidden headers, there is no element named email. If I send this request now, you can see we are getting a bad request with our custom message. Please provide a valid email address. Now let's see what happens if I provide an email header. And for the value, test@gmail.com. And if I send this request, see the same 400 bad request response with the error message. But if I provide a valid email address that does not contain the string test and send a request, we are getting the message welcome to home with a 200 OK status code. That's how we can add a filter to any Java application. Again, it's not specific to only Spring application. Spring Security makes heavy use of filters, but we can use them in any Java application to intercept requests and perform necessary validation. And it can also do this to every response that is coming from the application. So at this point, we know what a filter is. Now, let's try to understand what a filter chain is. Previously, we have seen a request come into a single filter. If it passes the criteria, the request is then sent to the application. But there are cases where we can have multiple filters. Let's say we have another filters here. So instead of passing the request directly to the application, it passes the request to the next filter. So the first filter passes the request to the second filter. Again, after processing the request, this request fits into the another filter. There can be a couple of filters, maybe dozens of filters based on the criteria. This request comes from this direction and passes to every filters. Similarly, the response coming from the application travel through all the filters in this chain. All the filters can check the response and do action on it if necessary, and eventually the response can reach the client. All these filters together creates a chain of filters, and this is called a filter chain. It's an important part of Spring Security. Here is another diagram from my previous tutorial on Spring Security architecture. Though it's not recommended, but I highly encourage you to watch it. Now, back to our diagram. Here, in this diagram, we have this security filter chain. The request comes from the client, and before our request eventually reaches the authentication manager, it needs to pass through this chain of filters. All of these filters together create a chain. This is why it's called security filter chain. Now, let's see this security filter chain in real code. Back to my IDE, I am going to include the Spring Security dependency in this project and show you the available filters in that chain. But before adding dependency, this is the code of our demo filters. Let's comment out this logic here. Instead of executing all of these, I would like to print a message in the console. So I will use system, then error. I'm using this error to show message in red. This will make it helpful for us to identify the message in the console. Then print line and give it a message. Let's also comment out these two statements over here. Now open pom.xml file. Here is our dependency block. After the Spring Boot Starter Web dependency, I am going to add our dependency for Spring Security. Let's copy this dependency declaration and paste it below. I will update this artifact ID to Spring Boot Starter Security. As simple as that. Now we need to reload the Maven dependencies here. So our Spring Security is now added. I also want to print the Spring Security related log in my console. By default, it is turned off, so I need to change some configuration to turn this on. Let's open application.yml file from resources directory. I'll configure our application to show all the logs of Spring Security at the trace log level. And another thing I want to do is colorize the text in the console. By default, the text in the console is shown in black and white, but I want to colorize them so that it can be more attractive. It has nothing to do with the actual production app. I just want it to make it look a little bit nicer during the development. Truly speaking, I just can't remember the exact logging pattern to add in the configuration to format the color. I used to copy paste it from my other projects, but now we have this AI. I can just command the AI to write me the code. This IntelliJ IDEA comes with AI integration. We can chat with the AI or command the AI agent, Juni, the AI coding agent by JetBrains, to help me write my code. Let's take help from the AI. To start chatting with my AI agent inside this file, I can simply press command and backslash, or I can right click, then AI action and generate code. Here in this input field, we can provide our instruction. update the application.yml file to set the Spring security login level to trace. Additionally, configure a custom console login pattern with the following visual styles. Display the time in green. Show the log level in blue with 5 characters of padding. Show the thread name inside brackets and colored red. Show the logger name in yellow, truncated and padded to exactly 15 characters. Display the log message at the end. And please ensure the YML indentation is correct. Now press enter. Let's wait for a couple of seconds while it generates the code. Here it is. It generated the code for me, setting the login level for Spring Security to trace and setting a pattern for the console with the instruction I have given to it. Click on this accept all to approve this. Now we need to restart the application to see all of this in action. Let's restart the application in debug mode. Stop and rerun. Our application started, and here you can see these console text are color coded. It's more visible and understandable than the default black and white text. Here we have this default password generated by Spring Security. Now, if we open the browser and open the URL that our application is running on, if we go back to the IDE and check the console, here we have a couple of new log entries. Check this one. Trying to match the request against default security filter chain. That is the filter chain defined by default in Spring Security. If we scroll a little bit, you can see the available filter registered under this filter chain. Here we have this log invoking disable encode URL filter. This is the one of the filters that is registered in the security filter chain. Beside this filter name, see we have this number in the bracket. This last number 16 shows the number of filters registered under the default security filter chain. This number can be vary based on your Spring Security version and your configuration. Later, when I show you how to add or remove filters, this number will change. Next to this, we have this 1. That means this filter, this disable encode URL filter sits at position 1. Whenever a request comes, this is the first filter that gets invoked. Then we have this web async manager integration filter. This is at position 2. So the request first entered the disable encode URL filter. After processing, if the request passed the criteria that is set by this disable encode URL filter, it forwards the request to the next filter at position 2, which is web async manager integration filter. Again, after processing this request, it passes it to the next filter. We have another filter, security context holder filter at position 3. Every filter has specific position and this position is strictly maintained. This filter chain is highly customizable. We can disable any filter in this filter chain and we can also add our own custom filter anywhere between other filters. Let me show you this. For that, I'm going to configure Spring Security inside Java, then our base package. I'm going to create a new package named config. Inside this config, I'm going to create a new Java class named security config. And I need to add annotation configuration. Here, I'm going to customize the default security filter chain. If you are familiar with Spring Security, you may know you can do this by defining a bean, each type of security filter chain. I'll give it a name. Let's say my custom filter chain, and this accepts an HTTP security object. Now, inside this method, we are going to customize our security filter chain. Now, before writing any code here, let me show you where the default security filter chain actually defined. We need to open a class named Spring Boot Web Security Configuration. For searching, make sure this all tab is selected and include non-project items checkbox is checked. Otherwise, you will not be able to get this result. Here, we are interested in this one from the Spring Boot Security Servlet package. Let's open it. Here you can see the documentation of this class is visible. If your case this documentation is not available, then you need to download the source code and the documentation. One way to do this is from your Maven tool. Open the Maven tool, then choose your project, click the download button and download sources and documentation. Now let's scroll down. Here we have the method default security filter chain. This is where the default security filter chain is registered and configured. This is the default setting. Let's copy this and paste it into our newly defined method. Here I need to provide exception in the method signature. Let's edit. Now let's see what it's actually doing. I hope you are familiar with these statements. Our first statement, this authorize HTTP request register authorization filter in the security filter chain. And if we check the console, here is our authorization filter. This is at position 16, the last filter that gets executed when the request comes to the application. And here we can restrict access based upon the servlet request using request matcher implementation. Then we have this form login. It registers the username password authentication filter in the Spring security filter chain based on the log in the console. This filter is at position 7 in the filter chain. This filter allows us to authenticate users by processing standard HTML login form submissions. Then we have this HTTP basics. It registers the basic authentication filter in the security filter chain. It allows us to authenticate users by checking the headers of incoming web requests for basic credentials. This filter is in position 11 in the filter chain. The other filters you saw in this console, Spring Security automatically registers them in the background. I don't want to dive into those right now. It would just overcomplicate the things, but I highly encourage you to check them by yourself. Now, let me show you how we can disable a filter. Here, I want to disable this CSRF filter. This is at position 5. To disable it, here we need to write HTTP, then call CSRF. This is responsible for registering the CSRF filter. Here, provide lambda expression CSRF.disable. With this, CSRF filter will be disabled. Now restart the project and we need to refresh the login page. If you check the console now, here this logout filter is shifted to the position 5. It was previously at position 6 and CSRF filter is not available in this filter chain. And you can see the number of filter registered here is now turns to 15. That is one simple example of how we can remove a filter in the filter chain. Now let me show you how we can register a filter in this filter chain. We have already created our demo filter and here we are printing a text message in the console. Let's check in the console to see if this demo filter is actually being invoked. See, this text is not present in the console. That means our demo filter is not being invoked because this demo filter is not part of our Spring security filter chain. So we need to explicitly register this in our security filter chain so that it can get invoked. Here, I want to include the filter before this username password authentication filter at this position 6. Before adding it to the security filter chain, the first thing I need to remove this component annotation. Adding annotation to make this filter as Spring managed bean, it can cause double execution problem and ultimately it can lead to authentication failure. Let me show you what the Spring security documentation says. At this time of recording, the latest Spring security version is 7.0.5, but in our project, I am using Spring Security 6. Let's check the documentation of this latest general release version. Here from the left sidebar, open Servlet application, then architecture. Here we have another menu on the right side that is outline of the content of this page. From that, click on this adding filter to the filter chain. Here it has clear documentation on how to add filter in security filter chain. If you scroll down further, here I want to show you this section. Declaring your filter as bean. See what this section says. When you declare a filter as Spring Bean, you can do this either by annotating it with component or by declaring it as bean. In that case, Spring Boot automatically registered it with the embedded container. That's great, but here is the problem. It may cause the filter to be invoked twice. Once by the container and again by Spring Security in a different order. That's the problem. But what to do if you really need to declare your filter as a bean or a component? Here it has provided the solution. If your filter needs to be Spring Bean to make advantage of dependency injection, that is sometimes we do need to auto-wire some component from the Spring context. If we have such scenario, we can tell Spring Boot not to register it with the container by declaring filter registration bean. Here is a coding example they have provided. You can use this example if necessary. Okay, back to our code. I want to include this demo filter before the username password authentication filter, which is at position 6. After we add our filter here, our demo filter will be at position 6 and our username password authentication filter will shift to position 7. Back in our security config, here to add the custom filter, we need to call http://add. Here we have a couple of options. First, we have this addFilterBefore. It accepts the filter instance we are going to add as first parameter. As a second parameter, it accepts the class type of the target filter. This dictates exactly where our custom filter will be placed. Then we have this addFilterAfter. As the name implies, we provide our filter instance and the class of the existing filter we want to place our filter after. There is also a standard addFilter method where you can just pass the filter instance and the specific position can be exclusively defined using an annotation in that filter. I am not going to cover that in this video. Actually, in my real project, I never use this option. There are cases where you might need to use it, but make sure you understand why you are doing. Another method is addFilterAt. Here, we put the filter we want to add. And for the second parameter, we need to put the name of the class currently sitting at that specific position where we want to place our filter. Our filter will then be added to that position. At this moment, let's check addFilterBefore. As I mentioned, for the first parameter, we need to provide the instance of our filter. For the second parameter, we need to provide the class of the filter we want to put our filter in front of. And in our case, that is username password authentication filter. Now, let's start the project. We need to refresh the page again. Then go back to the IDE. In the console, you can see our demo filter is successfully set at position 6 and our username password authentication filter is shifted to position 7. That's how we can insert a filter before an existing one. Now, let's explore the other option. Here is our addFilterAfter. This time, I want to add our demo filter after the username password authentication filter. Let's start the project. Refresh the page again. If we check the console, our demo filter is now at position 7 and before our demo filter, we have our username password authentication filter at position 6. Now, let me show you the addFilterAt option. I want to add the filter at the exact same position as the username password authentication filter. Let's start and see what happens. Our demo filter is at position 6 and our username password authentication filter is at position 7. But I want to mention a critical problem with this addFilterAt. Let's open the source code of this method. Here in the documentation, you can see it mentions that it registers multiple filters in the same location. That means their ordering is not deterministic. The order in which those filters are going to invoke is not determined. It can be any random order. It is highly recommended that you should not use this method to add a filter in your Spring security filter chain. Failure to position filter properly can easily lead to authentication failure. Okay, let's change it to addFilterBefore. Great. Now, we have understand of how we can add our custom filter to our security filter chain. At this moment, our demo filter implements the filter interface that is from Jakarta Servlet. But beside implementing this filter interface, Spring Security also offers other classes to define a filter. Those methods add some extra flexibility to work with Spring Security. Let me show you another approach. Another way we can create our filter is to extend a class named GenericFilterBean. That is from Spring Framework Web Filter. This class is part of the Spring Framework. If we check the documentation of this GenericFilterBean, this is an abstract class. It implements filter and is a simple base implementation of filter. If we run the project, refresh the page, in the console, we are getting the exact same result. The filter is invoked at the same position we mentioned earlier. In our project, we can use either GenericFilterBean from Spring Security or the filter from Jakarta Servlet. Either one will work perfectly. But the question is, when should you use GenericFilterBean and when should you use the filter from Jakarta? The answer depends on your application architecture. If you are building a pure framework-agnostic Java application and want your filter to run on any servlet container without relying on Spring dependency, you should use the standard Jakarta filter. However, if you are building a Spring Boot application and your filter needs to easily interact with the Spring environment, for example, reading application properties or accessing the application context, then GenericFilterBean is the better choice. It seamlessly breezes the standard Servlet API and Spring's powerful lifecycle feature. Okay, we have already learned the two options. Here is another option to create filter in Spring Framework. Instead of GenericFilterBean, we can extend OncePerRequestFilter. As the name says, this filter is invoked only once per request. Here, let's remove this doFilter method for now. Let's check the source of this OncePerRequestFilter. This is an abstract class and it extends GenericFilterBeans. So technically, it's a filter. Because it's abstract, we need to implement its required methods. Let's check the method. Here, we have this overriding doFilter method. When we extend OncePerRequestFilter, we do not actually need to implement this standard doFilter method by ourselves. This filter method contains necessary logic related to OncePerRequestFilter, ensuring that this filter will run only once per request. There are also some cases where this filter will proceed without invoking. Inside our doFilter method, Spring provides the built-in logic to guarantee that our filter executes exactly once per request. If we scroll down a little further, we have an abstract method, doFilterInternal. We need to implement this method. If we check the documentation, it has the same contract as doFilter, but it guarantees to be just invoked once per request within a single request thread. We'll implement it in a moment. Here, I want to focus on another method. Should not filter. There are some cases in the request where we should avoid filtering. We can override this should not filter method and put those exceptional cases here. If a request falls into an exceptional case, we need to return true. Otherwise, if we return false, it will proceed with filtering. Now, let's implement our doFilterInternal method. As you can see, this accepts parameters similar to our standard filter, HTTP servlet response, and filter chain. As before, let's print our log message and call doFilter, pass our request and response along to the next filter. Let's restart this project and refresh the page. If you see the console, our demo filter is positioned at position 6 and our username password authentication filter is at position 7 as expected. So at this point, I hope you have solid understanding of what a filter is, what a filter chain is, how to disable a filter, and how to include our custom filter in this filter chain. We also explored 3 ways to define a custom filter: using filter interface, using GenericFilterBean, and using OncePerRequestFilter. Another important thing I want to mention again: do not annotate your filter to make it managed bean of your Spring framework unless you are very sure what you are doing. Truly speaking, I made this kind of mistake before without knowing this. I just came to know while I was studying this topic for making this video. It's true, teaching others is the most efficient way to learn new things. From now on, I'll make sure I never do the same kind of mistake. Now, that's all about this video. See you in the next on a new topic. Please give your comment on what topic I should make video next. See you next time. Bye bye.